Hello, everyone. Well, today we're going to be talking about Waku. Waku is a decentralized protocol for messaging that allows you to send a message from point A to point B in a privacy-preserving way. And RLN, you may have seen it in the title, stands for Rate Limiting Nullifiers and allows you to rate limit the users in a network to prevent spam. So first of all, I would like to introduce you Franck, lead of Waku. He will be presenting the second part, and I will start with an introduction and some small workshop where I will show you how to join the Waku network by running a node and participating in our network. So this is the agenda for today. I will start with a Waku introduction, telling you what Waku is, what Waku is not, the future, the problems we have already solved in the past years. Then we will continue with the small demo that I told you before. It's going to be a quick workshop. I will share the commands with you in case you want to run them and in case you want to become an operator in the Waku network and relay traffic on it. And then Franck will talk about the need for a flexible rate limit in RLN and the economics behind Waku. So before explaining what Waku is, can you guys raise hands? Who knows what Whisper is? Okay, I see a bunch of hands up. I think I know everyone. Okay, so Waku is some kind of fork of Whisper, and it fixes most of the problems that Whisper had originally back in 2016, 17, something like that. So yeah, Waku right now is a suite of messaging protocols. And it's meant to deliver, as I said before, a message from point A to point B, or from point A to multiple points, like a group, for example, a group chat. It does so in a privacy-preserving way, without relying on a central entity. And it's generalized for any use case. You can build a chat application, but you can also build any decentralized application that you can think of. If you need to connect, as I said before, point A with point B, with these properties, you can use Waku. So we are not really binded to a specific use case. And the coolest thing is that it's permissionless for anyone. Anyone can join the network. So as I said before, Whisper had some problems, and Waku has solved most of them in the last years. First of all, latency. So in a network with the properties of Waku, latency is very important because the messages don't go directly from point A to point B, right? They travel through many nodes, jumping multiple times, right? So to fix this, we have limited the message size to 150 kilobytes. I will explain later why. And for the latency, there is also a trade-off between the replication factor and the bandwidth. I will explain this later. But yeah, long story short, we can guarantee to some extent that every message in the network will arrive within one second. Second problem that we have solved is the rate limiting. So in the Web2 world, it's very typical to rate limit with an IP, right? So if I see that your IP is sending more than X requests per second, I will stop you, right? Because you are not making a fair usage of the resources. But in the Web3 world, it's a bit more different because Waku, in the Web3 world, it's a bit more different because you don't have an IP to rate limit because you can't connect the messages to an IP. So we are using RLN, which stands for Rate Limiting Nullifiers. This was originally designed by the Ethereum Foundation, the PSE group, and we have adapted it. We have also some peer scoring. So to every peer in the network that you connect to, you keep assigning a score. And if the score drops below a given threshold, then we will kick out this peer from the network. So the third problem we have solved is the offline node. So your node could be offline for a few hours, days, minutes, or seconds. And someone may have sent you a message during this offline time. So for this, we have a store protocol and store sync to fetch these messages that you missed while you were offline. The fourth problem we have solved is the running Waku in resource-restricted devices because running a full node, as you know, like in Ethereum, right? You can't run a full node in your phone. It will drain the battery and you will run out of memory super fast. So for Waku, we have designed light protocols. They are called filter and light push. These light protocols allows you to use the network and publish a message, for example, on behalf of another peer. This allows you to run Waku in a mobile phone, for example, without consuming battery and data. Yeah, I will be talking about this on-chain Merkle trees a bit later. And yeah, last but not least, we have scalability. We have solved the scalability of the network by sharding the network in multiple shards. So we have split the network in different sub-networks. So I will zoom in each of the previous points that I have explained. Latency, let's start with the diagram on the left. Here we have, in the lower axis, we have the outbound degree D. If anyone knows about Gossip Sub, you will know this D. This is basically the replication factor. So how many times the traffic that you inject into the network is replicated. And on the other axis, we have the amount of hops that a message will travel in the network before arriving to all the peers. So the thing here is that, let's say that you set an N of 1,000 nodes. This is the amount of nodes. This would be the red plot, right? So let's say that you want a replication factor, meaning like the times that you replicate the bandwidth in the network of 6, for example. Then you will have a worst case amount of hops of 4, meaning that a message, after traveling 4 hops, it will arrive to all the peers. So as I said before, there is a trade-off in here between this and this, right? Because you can't have low latency and also low bandwidth consumption. So we were playing with this. So we have done some simulations. You can check them here. This is the distribution times of arrival of a message in the network. We were using different sizes, 2 kilobytes, 25, 100, and 500. And you can see this is the distribution. So in these 3 first plots, you can see that in the worst case, every message arrives within 1 second. This is why we have limited the maximum message size to 150 kilobytes. As you can see in this case, with 500 kilobytes, the average time goes quite up, close to like 1.7 seconds, and this starts to go quite high. So if you send in WhatsApp, it takes less than a second to send a message to your friends, right? So we should strive for something, similar. Cool. Let's continue with the rate limiting. As I said before, we use RLN, rate limiting nullifiers, to rate limit the users. So a rate limit example could be like, okay, we allow a user to send 100 messages every hour. The cool thing about RLN is that it does so in a privacy-preserving way using zero-knowledge proofs. And we can also act upon the rate exceeded. For example, if we detect that a given user has exceeded the rate limit, we can slash him or her. Yes, as I said before, this was initially started by the PSE at the Ethereum Foundation. So I will explain more detail about RLN. What does it mean? What is a membership? So basically, a membership, it's your key that allows you to participate in the network. This membership is stored in a Merkle tree that is on-chain, and anyone can register its public key on-chain. You have to only pay a fee. We have deployed it in Ethereum. By now, it's a Sepolia. It's a testnet, which is called Sepolia, but anyone can do it after paying a fee. So yeah, basically, we are storing this in the blockchain. We have this is your leaf. This would be you, and we have a Merkle tree representing all the memberships. Very easy. So the thing about RLN is that only the one who knows the private key of this public key can generate a proof, right? You can see this proof as some kind of a stamp that you will put to a letter. You will stamp to a letter. This stamp is, in reality, a zero-knowledge proof, and it allows every node in the network to verify that the message is correct and is respecting the rate limit. So yeah, it attached the message and it makes it valid in the network. You can think of it as a stamp that you have to buy in the post office and put it to your letter. Since the Merkle root of the tree that I showed you before is public, anyone in the network can verify that the message is correct. So you get the root, you get the message, you verify the zero knowledge proof, and you can decide if you want to accept or reject the message. So yeah, offline nodes, basically what I explained before, if your node goes offline for some time, you will have to fetch the messages that you missed. We have two protocols, store and store sync, and yeah, the latter is based in range-based state reconciliation. Regarding resource-restricted devices, we want everyone to be able to use Waku, even if you are running on a mobile phone. So for this, we have these two protocols, light push and filter. Light push allows you to send a message to the network via another node, and filter allows you to receive. You can think of it, we call them light protocols or edge nodes. You can think of them very similar to what Ethereum light clients are. I heard before a talk about the portal network. So this is very similar to that, because we can't assume that people are able to run both Ethereum and Waku in their mobile phones. We have one feature that we deployed to the Waku network quite recently that I think it's worth mentioning. So in order to generate a zero knowledge proof, you need to insert as a witness, if you know about zero knowledge proofs, you have to inject the Merkle proof of your leaf. The thing is that if you are a light client, you don't have this information, right? You would need to synchronize the whole tree locally and then be able to generate the Merkle proof. So long story short, we have done a modification in our contract, and in this contract, now we are storing the whole Merkle tree, and you can get both the Merkle root and Merkle proofs directly from the contract, meaning that a light client or an edge node can go to the contract, get whatever he or she needs, and then generate the proof and send the message to the network. So yeah, as I said before, you can generate proofs without syncing the tree locally. This is very nice because syncing the tree, as you may imagine, you have to synchronize many events, and this can take several minutes. And yeah, you can get the Merkle root and Merkle proofs from the contract, and these calls are gas-free because you are not changing the state of the blockchain. So the cool thing about this is that the gas increase in the membership insertion is very reasonable, so we can deal with it. Waku may move to a layer 2 to make to lower the fees, but even right now the fees are not that crazy. So yeah, RLN, it's working for light protocols. And yeah, scalability, nothing to add to what I said before. We split the network in multiple shards, and right now in the Waku network, we have 8 shards. Basically, if you know about Gossip App, we have one topic per shard. Okay, demo time. I hope this wasn't very painful. 15 minutes, not bad. If you are interested in following along, you can scan this QR code. I will leave a few seconds. You can also browse it. It's Waku.org and Waku Compose. Yes, if you have any questions up till here, I can take a few. Yes, in the demo, I will show you. I will show you, yes. Yeah.
Just a quick question. You say you generate a zero-knowledge proof every time someone sends a message, yes?
Correct.
How much time does it take to generate the proofs on average? Any idea?
Yes, we wrote a paper actually about this. It depends on the platform, blah, blah, around from 80 milliseconds to 150 milliseconds, depending if it's a MacBook, Raspberry Pi, whatever. But yeah, 100 milliseconds, it's a very basic zero-knowledge proof, because it's just proving that you are part of a given Merkle tree and that you respect a given rate limit. It's not like, in Ethereum, they are trying to prove blocks, and this takes like 2 hours, right? But yeah, thanks. Don't be shy. Cool. We will take also questions at the end, so no worries. Cool. So as a good engineer, I don't rely on the internet, so I have a video because I don't trust the internet. So yeah, what we are gonna do now, we are gonna run a Docker Compose setup that runs a Waku node, and we will also show you how to interact with your Waku node with a simple front end. And with this, you will be part of the Waku network, and you will join other nodes relying traffic. So let's start. You can see that the terminal is open on the right side. On the left side, you have the QR code link. We start with copying the configuration, the environmental file. Now we open it, and we have to modify a couple of things. We are using an Ethereum endpoint. You have to provide your Infura API key, for example. You can copy this, it's fine. You have to provide also your Ethereum private key. Do it only for testnet. You can copy this as well. This is the account. This account has to be funded with some Ether in Sepolia. And now we are going to register your RLN membership. This is a transaction that goes on chain to Sepolia and will give you the right to use the Waku network. It takes a few seconds because it's also waiting until the transaction is validated by the nodes. I will show later the fees we are paying for this. You can see also that it will appear here right now. You register your membership for a given rate limit. In this case, we have 100, meaning that you can send 100 messages every 10 minutes is the rate limit that we have defined. But you know, Waku is open source. If you don't like it, you can fork it and have your own rate limit. So yeah, you can see that the credentials are persisted. You can open the key store. It's a key store very similar to the Ethereum one. It's a bit different, but yeah, you can open it, a bunch of hexadecimal numbers. Now, yeah, this is the transaction. This is the smart contract, the RLN smart contract. This transaction is the one that we just submitted. We have 21,000 members in the tree. And I will open the transaction. You can see that the gas, wait 1 second. Yeah, it's consuming 150K of gas. This is quite reasonable, even for Ethereum mainnet. The function that is being called is the register function. This is your commitment. So it's basically the hash of your secret, more or less, and the rate limit, which is 100, as I explained before. Here we configure the store size. I set 1 GB, meaning that I will store only 1 GB of messages. And now we are ready to spin up all the services. This spins up some Grafana, Prometheus dashboards to monitor some metrics, the Waku node, the most important thing, and also a front end that allows you to interact with your node. You can check the logs if you are interested. For now, this is like you don't have to really understand it. And yeah, the first time that you start the node, it will take some time because it has to synchronize the smart contract. It will index all the events until it goes to it reaches the latest head of the blockchain. And once done, your node is ready. You will be relaying traffic of other people. You will have the RLN3 synchronized. Yeah, you can see here, this is the front end, localhost 4000. You can enter your username. And then you can join a group. I suggest if you want to join Devcon group, you can talk with other people. Here you can input your message, and when you click send, it will be sent to everyone that is subscribed to the topic Devcon. You can see that the message is there. Cool, so this was the demo. If you have any problems with this, later when we finish the talk, we can help you if you are interested. Quick note before I pass the mic over to Franck. This is cool, right? But I mean, I have WhatsApp, it works, that's the same. The user interface looks nicer. So why do you care about this? So first of all, you are running a full node, which is cool. You are relying traffic in the network, so you are helping others to communicate with each other. You also store past messages, and you have your own RLM membership. You don't have to rely on anyone. And yeah, with this, you are allowed to use the network up to a rate limit. This is cool, okay. But yeah, what's the advantage of using Waku? So first of all, the messages are not linked to any identity or IP. Every time you send a message, this zero-knowledge proofs doesn't connect your identity to the message. And also, since we are using GossipSub, to some degree, we can guarantee that no one will know your IP or will be able to connect your message to your IP. Also, you are fully sovereign. You don't have to trust anyone in order to use this. And it's decentralized because there is no single point of failure, and you are connected to multiple nodes using GossipSub. And yeah, with this, I will pass the mic over to Franck. He will be speaking about RLM version 2 and the economics of Waku.
Thank you, Alvaro. So, yeah, so RLNv1 is what we actually presented at last Devcon. I've been working on that for a while. And the past year, we have done several improvements and what we call RLNv2. Alvaro already touched upon the fact that now we have our Merkle tree on chain, which means that you can just do a smart contract call to get your Merkle proof and generate your proofs. Another change that we have is around the rate limit. So as we mentioned, the idea is that you generate a proof and it's attached to an epoch. So an epoch is just a timestamp with a granularity of choice. The first version of RLN, you could only rate limit to one message per epoch, which means that in terms of smallest practical epoch, 1 second would be the best. Under that would be difficult, especially considering network latency. And anything above 1 second, if you go for 10 seconds, 1 minute, then becomes impractical for a chat app, right? Because if the user has to wait, 1 minute or 10 minutes to be able to send the next message, not very useful. So also in terms of traffic, so why are we using RLN again? The idea is to rate limit how many messages can the publisher send on the network, so that we can cap the bandwidth on the network, so that when you use Waku on your mobile phone, on your laptop, on your household broadband, you know that you're not going to consume all your data, as well as you know that you can still be part of the network. If let's say you have 10 megabits per second at home, and that's what your internet can support, and someone comes in and injects a terabyte of data, you will not be able to receive all the messages and then forward them, as GossipSub tells you to do, which means that we misbehave in terms of GossipSub terms, and then you get kicked out from the network. All right. So if we have unlimited bandwidth, there is no capping of the bandwidth on the Waku network or on any GossipSub network, then you may get kicked out, which means that basically you have an outage, you get dust from the network, right? So with Waku, as Alvaro mentioned, we want to be able to have a decentralized peer-to-peer messaging, but also for laptop and mobile. We don't want people to have to use a centralized REST API. So back to the numbers. So with 1 message per second, and let's say we have a 5 kilobyte message size, so average, and let's say we have 1,000 users. So we think we can go up to 10,000 users on a given shard, but let's say if 10% of the users just continue to message, non-stop, you end up with 5 gigabits per second of steady traffic. So non-stop steady traffic. And you can imagine when you go back to a mobile phone or just having this non-stop traffic on your broadband is a problem. So with RLNv2, like from a technology point of view, the improvement is that now we can do n messages per epoch. So we're able to choose a number, and that allows us to have a wider epoch, right? So in our case, we chose a number of parameters, and we're going to start with that. Of course, we can change them as we learn more, as we use them in various applications. So currently on a smart contract, we went for 20 to 600 messages per 10 minutes. So we went for an epoch of 10 minutes, where you can use 20 to 600 messages. In terms of whether it's 20 or it's 100, it's up to the user. Once they insert a membership, they insert a public key to the smart contract, they can decide what rate limit they want to pay for. So we also have a rate limit on the contract. So on the smart contract, we have a parameter which is the total number of messages per epoch. So we set to 160,000 messages per epoch. And on the network layer, so more as a consensus between the operators on the gossip sub layer, we went for 150 kilobyte max message size. So now we have more of an API token-like, all right? So when you go, for example, to Infura and you get a free token for your RPC API, or when you pay for something, usually you're not going to get, you can do 1 request per second. Usually it's more like you can do X request per hour or per day or per month. Sometimes actually a bit of both. So now we have an API which is pretty much the same. So like you can buy a membership and this gives you, let's say, 100 messages per 10 minutes. All right, so just to go back to what we're seeing here. There you go. So the epoch are sliding, right? So 10 minutes. So for everyone, an epoch starts and then lasts for 10 minutes. And during this epoch, you can attach new proof to each message. Each proof will be different. And every node in the network knows that this key has used 1, 10, up to 100 proof. Because we use zero-knowledge technology, we don't know what messages, all right, are linked to the same proof, to the same key. Okay, so you still have this anonymity. So someone outside the traffic can't see that these 10 messages are coming from the sender from using the proof, but we do have the rate limit in place. And then after 10 minutes, when a new epoch starts, then we can forget about all these proof messages and we can start to count again. So with RLNv2, for a node to verify that someone is not exceeding the rate limit, they need to remember the nullifier. So nullifier is a piece of data in the proof. So for every message that goes through the network, they can check the proof and then store the nullifier for this epoch until the epoch finishes. So the nullifier is 128 bytes. So when looking at why 10 minutes, it's a question like why not doing 1,000 messages per day, for example, which would be much more flexible for a user, right? A user, most likely, if let's say in the context of a chat app, you use your chat app, 6, 12 hours a day, and overnight you're not using it. So every 10 minutes at night that you're not using it, you kind of lose the opportunity to use the chat app, right? So ideally, 24 hours will be better, but we do have some limitation, and that is around storing the nullifier for the epoch. So if we look at, let's say, 600 messages for an epoch, which is maximum rate limit for one publisher, this would be around 75 kilobytes per user, which means that for 10,000 users, it would be 700 megabytes. So 10,000 users, why 10,000? It's because we think this is kind of a good maximum size for a gossip sub network. So for one given network, you have to keep in memory up to 700 megabytes of data for this epoch. And if you can't keep that in memory, it means that you can't verify proof anymore. And if you can't verify proof, it means that you might forward spam, and you might then get disconnected by other nodes that did. So the memory usage is very important. And in terms of, just so we are clear here, this is about node on the relay network. In our case, it's both nodes as VPS in the cloud, as well as on the desktop. On mobile, we don't forward traffic, so we don't need this on mobile. But so if you Raspberry Pi, if you start to use more several gigabytes of data, we try to be a very lightweight client. So that's why we went for 10 minutes for now. We could always increase the epoch size or reduce it depending on when we use it with users and getting feedback. Another thing with the 10 minutes, which is good, is that if you go for a rate limit per day, so per 24 hours, one risk you may have is someone injecting, like publishing all the messages he can at once. And in this case, you can have a peak of traffic, and this peak of traffic may again lead to DOS protection. We think with these numbers, we think it's fine. However, if we were one day able to, let's say, compress the unifier or something like that and move to 24 hours, then most likely we may have to have like a dual rate limit where we may say we can do 1,000 messages per day and 100 messages per 10 minutes or something like that. So yeah, so basically like a lot of parameters to think about when deciding for rate limit. All right. So just trying to do some prediction, try to do some statistics. So in average, just doing some distribution, we could look at the traffic of 266 messages per second, and average message size of 4 kilobytes. So the maximum message size is 150 kilobytes, but we don't expect every single user to send maximum message size all the time. And actually, 4 kilobytes, looking at the status chat application that uses Waku, is actually a good average that we can see in our infrastructure. So Gossip Sub, we use Gossip Sub like Ethereum. 6, the out degree is basically the number of peers that you are connected to and forwarding message to, and also the number of, and these peers also forwarding message to you. So which means that with these numbers, we can we'll get around like a 6 megabit per second network, right? And we split our network, as Alvaro mentioned. We split our network per shard in 8 shards. So which means that now we, assuming uniform distribution between the shard, so assuming that network is uniformly distributed between the shard, we end up with a traffic of 75 or 0.75 megabit per second per shard. So much lower. That's what we discussed before with the one message per second. And that again, here it's these are statistics, right? So that's what we think would happen. But then, of course, it depends on the applications that use the network. All right. Any questions so far on RLNv1 versus RLNv2? So V1, we had to do 1 message per epoch, and now we can do n message per epoch, and it's much more flexible. So yeah, so that's one of the. So we basically three main improvements. One was the message size, so the number of messages, and the second one is the Merkle tree on chain, and the last one is we have defined some economics around the memberships. So just going back 1 second. So what's the point, right? So the point is when you want to send messages to the network, you have some rate limit. So you don't overwhelm the network, you don't overwhelm participants in the network, and practically dose them out of the network. So if we have a system where anyone can just grab any membership, then you end up having the same problem, right? Someone can come in and take all the memberships or take a high number of membership and attack the network. So you have to have some friction to ensure that you have to rate limit that as well, right? In some way or another, have some friction to ensure that no one just come in and grab all the memberships. In Web 2, right, in the normal, classical, I would say, world, you usually have some rate limit by IP. And that's why quite often, when you try to use VPN or Tor, you may have to have CAPTCHA. CAPTCHA is another rate limit, right? So rate limit by IP, rate limit by CAPTCHA, and sometimes you do have to provide some personal information, your phone number, your email address, social security number, and all of that. So in the case of Waku, we are trying to build privacy, anonymous, censorship-resistant infrastructure. And of course, so we wanted to be decentralized for that. So don't really want to collect people's phone numbers to allow them to have a membership. And that's why we use a smart contract. So now in terms of smart contract, I think there is many ways to do it, right? So we are currently looking at pure financial solution. But that's just like one example that gets us going without making too many assumptions. But you could definitely have things such as, actually I will mention that at the end. All right, so economics. So we now assume we're going to make people pay to buy a membership. So we went for 6 months membership. I mean, you have to buy a membership, and it's valid for 6 months. And at the end of 6 months, you have a 1 month grace period. At the moment, we went for a linear price, all right? So we say, okay, let's pay 5 cents per message per epoch for your rate limit. So if you go and buy the lowest membership, which is 20 messages per 10 minutes, you pay $1. And if you went for the highest rate limit, you pay $30. In terms of gas cost, so I think our demonstration was using a contract that didn't have yet the economics in there. So now actually we just look at the test, and it's around 232,000 gas to insert a membership on the smart contract with the economics in there, which is around $10 a minute, which is, for 6 months. It's not the end of the world. Looking at L2s, it will be more like around 70 cents, of course, depending on the L2 and the current gas price. So at the end of the 6 months, the membership can be extended during the grace period. At this point in time, we are not trying to lock in money, like to make money from that. So it's a deposit, all right? So at the end, if you want to extend your membership, you just call the contract. You're going to pay gas to call the contract, but you don't need to put more deposit in. And if you want, you can also withdraw your deposit during the grace period, after the grace period. If people just insert a membership and they just leave it there, as I mentioned, there is a global rate limit on the smart contract, right? So the smart contract will not accept membership above a given limit, which was 160,000 messages per epoch. So if there is no more space in the Merkle tree, then a caller can override expired membership in there, so that if people don't renew, we don't have to extend the membership on the contract. We can just, the caller can just override. A quick mention, so we do have, cap on the rate limit on the contract. So what happens if we have a network with that many users, right? As we mentioned, we do split the traffic in 8 shards. So the idea is that if we end up at a point where the smart contract is full, and we do see this traffic on the network, then it's always possible to potentially deploy a new smart contract, or maybe modify the current one, like change some parameters, and add new shards. And to add new shards is just a consensus between operators. So just saying, okay, operators, let's have a new shard on the network, maybe a new smart contract with a higher rate limit, so that we can scale the network and get more users in. Cool. So, all right. So that's the current status. We are still refining the smart contract, more or less ready. We try to deploy it on mainnet very soon, probably in an audit first. In terms of the future, so we went for 6 months membership. Probably we can do 1 year membership, but it's still quite early on, and we didn't want to, lock in parameters and having to try to get people to migrate if we change things drastically. But most likely, a yearly membership will make more sense. At the moment, we have linear pricing, right? So, 5 cents per message per epoch. We could have non-linear pricing. So actually, we already prepared the smart contract for that. So that, for example, you could have a bulk discount if you go on the higher end, or on the contrary, try to make it more expensive to have a higher rate limit. Now we need to basically get it used so we can get some feedback. One of the changes, so the reason Waku was built was for the status chat app, which is a chat application, both mobile and desktop. New version 2.31 just released, so go give it a go. So right now, the next step to have RLN used is for us to get it in the status chat app. And the main challenge here is to look at the current chat protocol and understand what would be the impact to reduce to rate limit, to add this hard rate limit. All right. So another point is that, especially when you think about chat application, I know WhatsApp used to cost $1 a year, long time ago. I don't know if you remember that. It sounds, okay. Anyone project developer that wants to build on Waku and want to take advantage of this decentralized peer-to-peer network might say, I don't want my user to pay and to do on-chain transaction before they can use the application, which is a fair comment. So we have considered having message going for free on the network, but it would just make the network more unreliable. So instead, question is like, how can we offer free membership to users, which is counterproductive, right? Because again, it is the right limit to avoid people flooding the network. But there are some options. So one interesting option is stealth commitment. So stealth commitment allows you to have someone else insert a membership for you and revealing very little information about your own membership. We could use Paymaster, right? So if you look at at layer 2, you could deploy a Paymaster to say, all right, if someone tries to insert a membership and they have some on-chain history, for example, they already bought an ENS name, or they do have some ETH, or they have some specific tokens that you are interested in or related to your project, you could say, okay, this user has on-chain activity, they're already part of my ecosystem. When they go and try to buy membership, I will pay the gas, pay the fee for them. And finally, a referral system. So one I think very interesting one is at the end of the day, you just have to enter a specific number in smart contract, like the public key, and there is a way to do that as well without revealing too much about it. So you could just have a referral system where someone that is already has an Ethereum wallet, already has gas, is to pay gas, could insert the membership for someone else. Again, once the membership is inserted, you don't have to do anything on-chain anymore. All you have to do is do some calls on the contract to get Merkle proof, to get your index, and then you can generate proof and publish on the Waku network. All right, so that's the most part for the presentation part. Any questions on cost and membership? Don't be shy. All crystal clear? Yes, Q&A. Are you doing it? Or? All right. Oh, awesome. Questions. Awesome. No question. If your node closes often, do you need to resync every time before sending? No. So you do not need to resync messages per se before sending, at least at the routing layer. Okay, so if you miss messages from the network, then you miss messages, and then it just depends on what is your application, and in this case, and then it's up to your application. If your application is a chat application, then maybe you will want to retrieve messages because there are chat messages you are interested in. In terms of the smart contract, when you restart, you do need to check the latest Merkle proof from the smart contract, because you do need to have the latest Merkle proof to generate the proof, right? If you use an old Merkle proof, then your message may be rejected. So you do have to recall the smart contract to double check to get the latest Merkle proof, and you do have to watch the smart contract as well, right? Because every time someone inserts a new membership, the Merkle proof change. The Merkle root change, and hence you have to have a new Merkle proof. You have to use a new Merkle proof to generate your proof locally. So you don't need to do a big resync per se. First top question done. Is a deposit necessary since the transaction is needed anyway? Wouldn't just the gas paid be enough friction? Yes, no, that's a good point. It's a good point, especially on mainnet, where it does cost some money to interact with smart contract. However, here's the question is about security assumption, right? So how much should people pay to get a membership and send on the network? That's something that we have some theory around it, but we need to see practically what happens. And most likely you prefer to use the L2 so things can go faster. Like most applications, more and more are using L2s, and on L2 it's very, very cheap, and hence the question becomes moot. So because our aim is to deploy L2s, and we develop this strategy. If indeed someone wants to use RLN on the L1, they might decide that the gas cost is enough, and that's fair enough. So I think I replace one. Is there a way to pay the membership for another user/account as a way to onboard Web2 users, for example? Yes, absolutely. So, so buying a membership, you're just interacting with a smart contract, right? And you are just sending a commitment, right? So you're just sending a number to the smart contract with the payment to have the rate limit. So you can get this number directly from your friend and then do the smart contract call for them. All right. As long as they know to check this smart contract, they don't have to pay gas. And with test commitment, you can also have a bit more privacy around this action. So yes, absolutely, you can onboard other users and pay their gas fees and their membership fee. Are you considering limiting by n megabytes per epoch rather than messages count per epoch? So yes, we actually thought about that. We actually look into that. If I remember correctly, and I'm looking at my researcher, yes or no, is that it just makes it more complex. Much more complex, right? It makes it much more complex. So that's why instead we went for message count. And I think RLNv2, right, would help for that as well. Or am I confusing? Maybe, okay. So yeah, it's much more complex. So instead we have an agreement between node operator of the message size so that they can decide to drop messages which are too big from the network. And you have the message count on the smart contract. Is there, can you scroll down, please? I think I replied all these questions. I think there is more. Yeah, scroll down a bit more. Scroll down. Yeah, okay. Are there any more use cases that can be applied with RLN? Yeah, absolutely, absolutely. So again, RLN comes from the privacy and scaling exploration group from EF. So at the end of the day, with RLN is you rate limit the number of valid proof you can generate for a given number. In our case, the number is an epoch, and we use that so as a timestamp, right? But let's say you could do voting, right? You could have a proposal. The number is a proposal number, and you can say, okay, you can do one vote per membership, and you could vote in an anonymous manner. I haven't looked lately about RLN applications, but yeah, it can definitely be used for other applications. Have we considered risk-taking to secure this instead of introducing a new token economy? Do you know, Alvaro? Yeah.
So, yeah, that's an interesting question. We haven't. That's the short answer. But could be interesting, actually.
There you go. Would upgrading from RLNv2 to v3 in the future be a breaking change that would make nodes on the previous versions not work with the new ones? Okay, so first, not sure we would ever upgrade to v3, but in any case, it is a consensus, right? So in short, when you run a gossip subnode, all right, you are going to have rules to validate messages, and everyone needs to have the same rule, because otherwise you get spam and you're going to say, okay, this guy is sending spam, so I'm going to disconnect from him. So whenever you want to upgrade the network and change the smart contract, there are several ways to do it. You can just start to point to the new contract, and you're going to disconnect people that are still pointing to the old contract and connect to people that are pointing to the new contract. You could have, and I think that's basically like the main strategy here. Because as soon as you could have strategy as well where you say, okay, from this point, from this timestamp or from this block, we are going to start considering messages valid from a new contract or from a different contract. So it is somewhat of a breaking change, but gossip sub has self-healing properties, right? So it wouldn't last for days and you have a hard fork or anything like that. It would be more about a question of having the gossip sub peer scoring mechanism to kick off and heal the network. Can you scroll down, please? Yeah. Oh, all right. Do we pay in ETH or some other token? How is this 30 USD paid? Yeah, it was on the slide, but I didn't mention it. So at the moment, ERC20 token, All right. This is a parameter of a smart contract. So when you deploy a smart contract, you can decide which ERC20 token you want to use. In our case, we thought it was important to use a stablecoin. So we went for DAI, because we are decentralization maxi, so we went for a decentralized coin. So we suggest to use DAI, but it is a parameter of smart contract, and you can just choose whatever you want when you deploy it. Potential way can fill the tree with membership very quickly. Is there a way to mitigate it? I'm remembering the discussion. We had quite a few discussions around that. So yeah, at the end of the day, a whale could come in and fill the tree. And this is one of the reasons I think expiry is very important, right? Because if they do, then we have to cost enough so that they do it again and again and again. So in terms of security, at the end of the day, any security problem, the question is, what is the cost opportunity versus what could you gain, right? Quite early stage here, so someone would do that, it would be just quite annoying, but we just deploy a new smart contract and just get the node operator to point to the new smart contract. We did think as well about limit, like, saying, okay, one membership per Ethereum address, for example, per wallet, right? But this could be, you could still go around by just, dispatching your money on several wallets. So I think at the end of the day, expiry does play in there. I wonder if Sergey has more to say about that. About the whale problem. No, okay. It is a fair comment. It is a fair comment. Okay. I think no more question? More question from here? Awesome. Anyone has tried the Nwaku compose? Oh, right now. Do you want some help? Is it working? Or you tried it in the past? Do you need some Sepolia is? Yeah, we can help. So, okay, cool. I think we can stop the presentation for now, and then we can help anyone that wants some help or some questions.